Hi everyone. Today I want to tell you about another method for finding zeros of polynomial functions. But first, let's talk about an old parable. This is a bird and this is a fish. Why can they never fall in love? Broken heart. The reason, according to the parable, is that they would have no place to make a home. Because if you think about it, if we wanted to make a path between the bird and the fish, any path, it's got to cross through the water some point. It has to cross through the surface of the water. Whether the bird goes to the fish or the fish goes to the bird, any way they want to go, it has to cross the water somewhere. And teleporting's not allowed. So the fish can't just go from here and then hop to here and go to the bird. They're not allowed to teleport. They must go through the water. There's actually a mathematical concept behind this. It's called the intermediate value theorem. And the idea is that if you have a point on a graph which is below y equals 0, and a point on a graph which is above y equals 0, then if you have a continuous path between them, you have to cross y equals 0, which means that the function f of x equals 0 for some value of x, because y is representing f of x, right? So the fish and the bird can never be in love because any path between them crosses the surface. If you start below the x-axis and end above the x-axis, as long as you're traveling in a continuous way, you have to cross that axis. You have to break through the surface of the water, make a splash. So here's the theorem in a simplified form. It's actually a bit more complicated than this, but we only need the version about zeros for our class. In Dr. Engberg's class next year, you'll learn the version that is more general. So let a and b be real numbers where a does not equal b. So a is going to represent a point along the x-axis. B is also going to represent a point along the x-axis. Now, if f is a continuous function, that's the whole idea of not teleporting. We have no holes or breaks. We travel in a smooth way. So the path a fish would have to take, or a path of flight the bird would have to take, continuous. So if it's a continuous function, such that f of a is less than 0, so the position of the fish is below the axis. That's all that means. And f of b is greater than 0, that just says the height of the bird is above the axis, then there is a 0 between a and b. There's an intercept. So that just says there is a place where f of x equals 0. And it's got to be for some x between a and b. So for some value along the x-axis between a and b, there's got to be a 0. This is actually a result of the fact that we have a function. If you think about it, we could, if we didn't have a function, we could have our 0 be before a, and then we could still make it to the bird, but this wouldn't pass vertical line test, so that's not a function. So the 0's got to be between a and b. So continuous and a function, one of the values is below, one of the values for y is above, then somewhere between those x values we have a 0 or a root or an x-intercept. All those words are synonymous for us. So now I just want to show you an example of how this can be used in order to approximate the location of a 0. So here's our function, x cubed minus x squared plus 1. We want to approximate a 0. So the first question we need to ask is this a function? And yes, it is. The parent function is x cubed, and then we just do some transformations on it. So it's definitely a function. The next question we need to ask, if we look back at our theorem, is this a continuous function? So it's definitely continuous because the function we're dealing with is polynomial. And one of the very first things we learned about polynomials is that they're continuous. They have no holes, no jumps, and in fact, they're actually smooth. So the other part of the theorem that we need to satisfy is we need to find an a such that f of a is less than 0 and a b such that f of b is greater than 0. Then somewhere between a and b we'll actually have a 0. So we need to find our fish and we need to find our bird. So I want to do that by using this function table first. So we could calculate this by hand if we wanted to. So when x is -2, f of x, we're going to plug in. So it will be, oops, I'll move this. So -2 cubed minus -2 squared plus 1. So this is -8 minus 4 is -12 plus 1 is -11. So the point -2 minus 11 is on our graph. So I can go ahead and put it on the graph. But instead of doing all this work, let's let the calculator do it for us. So here we'll plug in x cubed minus x squared plus 1. And I'm going to make my window x min -5, x max 5, scale is 1, y min -12, y max 10. We can look at the graph. And from here, I can look at the table. So if I look at my table, let's actually change the table so it differs by 1. So all I did was press second window. That took me to the table setup. I want it to start at, let's say, -3, and our change in the table in each step is 1. So now let's look at the table again. So when we plug in -3, we get -35. When we plug in -2, we get -11, which we knew. When we plug in -1, we get -1, so I'll fill that in on my table. So that means the point -1, -1 is on my graph. When I plug in 0, I get 1. When I plug in 1, I also get 1. So 0, 1 is on my graph, and 1, 1 is on my graph. We can check the graph here. So it looks something like that. So I'll just connect up my dots so it matches the graph we just saw. So from the graph, we can already estimate where the 0 is. But we want to do this using the intermediate value theorem. So I need to find an f of a, which is less than 0, and an f of b, which is greater than 0. So here's one. F of -1 is less than 0. Here's one that's greater than 0. F of 0 is greater than 0. So I know that somewhere between -1 and 0, I have a 0. So somewhere in here, there's a 0. So that, the intermediate value theorem gives me an estimate. It tells me that somewhere between -1 and 0, I have a 0. I can do a little bit better. So let's calculate 2 more values. So one answer is there is a 0 between -1 and 0. Now, if I do, so let's go to second calc and look for the value when x is, let's say, -0.8. -0.8. When I plug that in, I get -0.152. So here's a better answer. F of -0.8 equals -0.152. So that's less than 0. Now if I plug in, so I'll go second calc again, value -0.7, f of -0.7 is 0.167, which is greater than 0. So here's my fish, here's my bird. The x value for the fish is at negative 0.8, the x value for the bird is at negative 0.7. So somewhere in between them there's a 0. So there is a 0 between negative 0.8 and negative 0.7. And that's a much better estimate. So you could keep refining this and getting better and better estimates by now looking at values for f of negative 0.79 and negative 0.71, and you could hone in on that 0 by looking at more and more values. So that's all for this video. This is a really useful tool and it's extremely helpful in calculus. So whenever you hear about intermediate value theorem, just think of the bird and the fish.